Hi, my name is Daniel Kim, and my presentation is from a paper called Review of Performance Metrics for Green Data Centers, a taxonomy study. It was in the Journal of Supercomputing. This paper is not free, but I was able to download it from the author's site. Uh, this paper talks about the importance of metrics in order to achieve green data centers or sustainability. Over 1.5% of electricity in the US is used just for the data centers, so it will continue to rise with the trend of the popularity of the data. A lot of data center markets themselves as green computing, so it has almost become a marketing tool. However, we need to know if they are truly green or if they are just adding few machines that are green and calling themselves green. The users also need to be aware, as well as the data center owners, and we need to know how green the data center is. There are two key features of metrics and the goals of sustainability. One is concerned about saving money when going green. The other is concerned about the environment, especially in reducing harmful emissions to the environment. There's also two types of benchmarks. Server level benchmark is concerned about the server and how much power it's using. The data center level benchmark is measurement for the entire data center. These are the server level benchmarks. As you can see, there are quite a few. They're concerned mostly about the performance and the amount of power in terms of the kilowatt that the server or the computer is using. Data center level benchmarks are dealing with the entire data center, and they evaluate how green data center can be. It's used for comparison between data centers. One important organization is the Lawrence Berkeley Lab, National Lab. They release the best practices for sustainability in the data center, and also they release benchmarks as well as metrics that they rely on use. There is a formal process for benchmarking in a data center, and as you can see, this is a flow chart. I think the one important part is setting goals and collecting data, and at the end, make sure you have the follow-up action plan. There are some challenges to designing and creating metrics. First of all, there are a lot of roles in the data center, like owners, administrators, and users. So it is very difficult to define useful work because everyone has their own view of what a useful work is. Um, and there's also a lot of different mixtures of hardwares and softwares in the data center. So it's very complex, and at the same time, the environmental cost is very difficult to define. Uh, there's parameters such as the temperature, power, and humidity. Performance metrics for green data center computing are divided into two categories: the basic metrics and the extended metrics. And this is the graph that, or the chart that shows performance metrics taxonomy and how different metrics are separated into different categories. One important metric to measure is the greenhouse gas emission. The primary one is the carbon dioxide, or CO2. It is a main contributor to greenhouse effect, so it is important to measure the output of CO2 as a result of the power consumption from the data center. There's one way to estimate this CO2. Um, if you look at the next chart, you can see how much of CO2 is emitted depending on the source of your electricity. For example, if you're using coal, then you're emitting a lot of carbon dioxide per kilowatt as compared to a green energy source such as the hydroelectric or wind power. Humidity is a measurement of moisture content in the air. Humidity is really bad for computing equipment, so the data center usually tries to control humidity, and this RHD, or relative humidity difference, can be used to find opportunity to reduce energy use if there's actually humidification and dehumidification within the data center. There are a lot of thermal metrics. Thermal metrics is very important because up to 50% of the total energy cost in data center is used for cooling. So this is very important, and there are quite a bit of metrics. Um, One important is metric is the data center temperature. About 68 to 75 degree Fahrenheit is optimal, and the temperature is usually measured between the supply and the return air. BTU is the amount of energy required to raise the temperature of a pound of water 1 degree Fahrenheit. We use BTU to determine how much energy is used for temperature control. Airflow Performance Index measures the performance of airflow within the data center. It requires a lot of temperature sensors within data center, and there's quite a bit. Cooling system efficiency metrics measures the efficiency of the overall cooling system, including the chillers, pumps, and cooling towers. Um, Airflow efficiency measures the efficiency of airflow in terms of the fan power required per unit of airflow. Cooling system sizing, or CSS, can be used to determine the scalability and the potential of the current cooling system. AEU is useful for data center in colder climate where air economizer can be used to provide free cooling during certain parts of the year when it's cold, instead of using a chiller plant. These metrics are probably the most popular metric because it's also the easiest to measure and easy to calculate and analyze. We've already seen the PUE and DCIE from our previous class. HVAC system effectiveness is the fraction of the IT equipment energy to the HVAC system energy. Having a higher value of this metric compared to other data center means that there's also higher potential to reduce HVAC energy use. SWAP and DCEP also measures energy use in terms of power and other parameters such as space, productivity, etc. Total cost of ownership, or TCO, represents the cost to the owner to purchase, build, operate, and maintain a data center. It's usually measured in terms of dollars per watt, and it can be split into two parts: capital expense and operational expense. The capital expense is the initial investment for purchasing and building the data center. As a rule of thumb, building a large data center typically costs around $12 to $15 per watt, and smaller data center costs more. In general, 80% of capital costs goes to power and cooling infrastructure, and constructing a data center costs about the rest of 20%. Operational cost refers to recurring monthly cost of actually running the data center. Typically in the US, to operate a large data center costs around 2 to 8 cents per watt, excluding electricity cost. In conclusion, there are a lot of good metrics for data centers which are designed with sustainability in mind. We've seen a lot. Also, I think that we can develop more metrics in the future, and in order to do that, perhaps we may need more sensors or even develop better sensors, not just temperature and humidity. Metrics also promote sustainability, and as a marketing tool, data center can market itself as having a very good PUE or DCIE to potential customers. Perhaps certain metrics like the airflow metrics can pinpoint problem areas. Metrics like the TCO can also show justification for green data centers and sustainable data centers. Thank you.